Hey guys, in this quick video, we are going to be looking at MariaDB Hashicorp Vault plugin. So this plugin is able to talk to an existing Hashicorp Vault. That Vault basically is your key management system or KMS to store your encryption keys, right? So those encryption keys, of course, are going to be used to encrypt your MariaDB data at rest, right? So the once that is configured properly, or once the MariaDB server is configured properly, we would be able to see that all the data files on the server storage is actually now encrypted. So the scope of this video is basically to configure a MariaDB server with the vault configuration, and then see how we are able to connect to an existing vault, and how we are able to fetch those keys, the key that is already stored in the vault, and then also how the key rotation works, right? So we are going to take a look at all those things later on, but at a very high level, we are also going to do a very basic vault installation using the vault binaries. We are not going to be using the repository manager or things like that. We are just going to be simply installing the binaries, or copying, downloading the binaries, and configuring a service for that, right? So very basic setup, and you will see it's very easy. And then yeah, let's go ahead. I have already downloaded the Linux version of this binaries, a 64-bit version already downloaded. So if I minimize this, these are the two servers that I have. One is running MariaDB server enterprise version 10.6, and the other one is running the is going to run the vault, right? So it's not yet running. So let's take a quick look at this one. All right. Yeah. So if I check the listing of this folder, I can see that the vault is already downloaded. The 191 version is already downloaded. So before we can unzip this file and start using it, we will need to create a set of directories or folders. So let's create a Hashicorp Vault bin folder first of all, and then yeah, and then let's create a data folder, right? So, and then finally we are going to create a configuration folder or a config folder. So this is going to be used for storing the configuration for the Hashicorp Vault, and then this one is going to store the data, the Hashicorp Vault data, and this one is going to store the binaries, the Vault binary itself. So now let's move this Vault zip file into this bin folder. First of all, mv vault into this particular folder. So if I go to this folder now, I should see that file already there. Let's unzip it, vault, and then taking a quick look, we can already see that it's extracted a single executable file, the vault executable file. So that's pretty much it, right? So this is the vault, and then this is what is going to be doing the execution for the vault itself. All right, so this is done. So let's add this path to the profiles folder, so that we are able to access this vault executor from any folder that we wanted. So let's do that, and let's source profiles. So once this is done, so if I go to another folder, vault, if I try this one, it should be able to access, and we can already see that the vault is running, or this particular vault is basically 191 version, right? So let's go back to that folder, and yeah, we are going to be creating another file now. All right, so this is going to be my configuration file for the vault. So let's clear the screen. So again, the configuration file as we created earlier under the Hashicorp config. So we are going to use that folder, but the file name can be anything, but I'm just using this vault config HCL file because the configuration syntax is using HCL format. So let's put a template here, and not really a template, but is a proper configuration for this vault. Let's do that. Yeah, there it is. So now we can see that the first parameter of first config is the file path, the storage parameter. So the storage is going to be using file-based storage, and then is the path is going to be Hashicorp data. And you remember this folder also we created earlier on together with the bin folder and the config folder. So this is where the data is going to be stored. The listener configuration is going to be listening to this particular bind address with the 8200 port number, and then the API address is localhost, pointing to localhost 8200, right? So this API address is required because whenever you want to connect to the vault or you do some execution from local on this machine, this API address variable must be defined. Then we can see that under this listener, the TLS is disabled basically. So we are going to be keeping this setup simple. So we are not going to enable that the TLS. So if you want to enable TLS, you need to set this to 0, and then of course later on you will need to have a set of client keys and then the server keys that we are going to use for both MariaDB and the Vault to communicate in an encrypted manner, right? So just set it to 0 if you are going to be using a TLS, and then you will need to have a set of CA certificates and keys basically. All right. And then finally, if you look at this one, the log level is currently set to trace, which is going to be very detailed, right? So normally you would set it to warnings or log errors, but because this is our first time setup, so we just want to keep it a bit more detailed. So if let's say we run into some problems, we can easily troubleshoot those. So yeah, that's about it. So just save and exit this file. The file is created now. Regarding the storage that was defined in this one, let's take a quick look at that one again one more time. So this storage can be on S3 as well, right? So if you want to store your data and everything on S3 bucket, right? So you can do that. So you need to define storage as S3 here instead of file, and then you need to specify your S3 specific parameter like access key, secret key, and bucket name, things like that, right? So those things you need to define in your config file here, the HCL file. All right, so the config is done. So let's try to start the server first of all, see whether can the server already start with this basic configuration file. Right, so let's do that. So we'll use the Vault executable, right? So we don't necessarily have to be here. We can do it from anywhere we want it. So let's do that. If we go to root folder, yeah. So let's start the server from here. It should work. Yeah, it works. And then we can see that the listener one is already running and is listening at this particular TCP address. And then of course, yeah, everything looks okay to me. There's no issue. Storage is file and Vault version is this one. So everything looks all right to me. So yeah, that's about it. So we'll just Control C here, and then we'll see that the server has actually shut down now. So the Vault is no longer running, but our basic test is successful. So now, because we don't want to be running the server or Vault using this executable command, right? From here, we want to be able to run it through a normal systemd service like systemctl start stop status of a Vault. So to do that, we would have to create a file under etc systemd system/vault.service. So we'll create a file by this name. So it's going to be our service file, and then let me copy a set of blocks here so that we have a definition done. So we are defining the unit as Hashicorp Vault, right? And then we are going to be defining the environment file as etc system sysconfig vault environment file. And then the most important one is of course this executable path. So executable, how is this service executed or started? So it's going to run Hashicorp Vault bin Vault executable file with the server parameter, and then the config file is going to be this config file, the one that we created earlier. So this, if you look at this command looks very similar. Basically, is the same command that we just now executed with from the command line. Right? So now this command is going to be running from the service file itself. Right? So yeah, that's all there is. So just save and exit this one. So our service is done. So before we could make use of this service, we will need to do a daemon reload, because we have just modified or created a new service file. So we need to reload the system D daemon. So let's do that. And now if we do a system start vault, we are able to start it. Systemctl status vault. If we do a status, we can also see the vault is running. So everything looks good for now. Our service is ready, and yeah. So now if we take a look at the vault status, right? So let's take a look at the status of the vault itself. Vault status. We can see that this doesn't get executed properly, right? So it's not able to get the seal status first of all, because the API address is not defined, so it's not able to connect to that API. So for that we would need to basically export a variable or set an environment variable called vault address that is pointing to localhost. So this is only going to be required for localhost communication. You don't need to set it later on. So this is just a one-time activity, right? And then also we want to make sure that we set this variable in the etc profile as well, just like we did previously with the path. We want to make sure that this is done. So now that this variable is now already set to localhost 8200 8200, if we do the vault status now, we should be able to get that status, right? So that status is now giving us that the sealed status is true. The vault is currently sealed, which means that nobody can get the keys from there, nobody can create a new key, and nobody can do anything at all on this server. All right, so now is the time to initialize the vault, right? So let's initialize it first of all. I'm going to clear the screen. So vault operator init, so it's going to create an initialization file here with some configuration that we're going to review very quickly later on. So yeah, the file is created, the init file is created. Again, this is also a one-time activity. So if I do a cat of this file, yeah, let's take a look at it. So this file is a very important file, right? So this file contains the 5 unsealed keys for the vault. So if we want to unseal or basically if you want to use the vault for MariaDB or for any other purpose, we want to make sure that the vault is unsealed, right? So MariaDB will not have access to these keys, and MariaDB will not be able to unseal the vault on its own, which is of course a very the proper way of doing it. So MariaDB or any other client should never have access to unseal the vault or by itself. And then we have a root token. So this root token is something that is going to be configured in the MariaDB server. We will see that later on. But for now, just take note that these unsealed keys are going to be required for sealing and unsealing the vault. Whenever we restart the vault is going to have to be unsealed. All right. The important point here is that these keys are very important, and these should never be left in this file. So once this file is created, we are supposed to be distributing these keys among real people, right? So maybe they are DBAs or maybe they are some other security team folks. So we need to distribute these 5 keys to 5 different people, or at least 3 different people, so that whenever there's a requirement or whenever we want to unseal the vault, we get help from them, so that they come in and then they type in those keys. So these keys should not be available with anybody else other than those real people, right? So that's an important concept to take note of. And that this token, as I mentioned, is going to be configured in the MariaDB server itself. So for now, I want to keep this handy. So let's yeah, so we will need to access this file again later on once we are going to unseal the vault. But yeah, so we can also see vault status. We can see that the sealed is currently true, right? So this vault is currently sealed, which is what we expected. All right, so now let's create a first our first secret, right? So our secret name is going to be MariaDB. So we are going to create a MariaDB secret using a key value pair. So the command is again very simple: vault secrets enable. So we are going to enable a KMS a secret file secret basically under this path slash MariaDB, and then the version 2 basically means that this secret is going to be supporting multiple versions of a particular key, right? So that's also we are going to see later on. So v2 or version 2 is basically for having multiple versions of a particular key, right? So let's enable this. Oh, yeah. So we still cannot enable it because the vault is currently sealed, of course, as expected, because the vault is sealed. So we are not allowed to do anything at all on the vault, right? Not we are not allowed to add a key. We are not allowed to get a key, or we are not allowed to enable any secret managers. So yeah, so now we want to unseal the key. We would need three of these keys, right? So any three keys, not necessarily one, two, three, any, maybe this one, and this one. So that will work. So let's copy this first one, and then I'm going to use the command vault operator unseal this one, right? So this is, let me see which key is that. Yeah, this if is the first key. So I'm going to unseal using the first key. So now we can see that the unseal progress is basically 1 by 3. So we need to use or unseal 3 times. So one is already done. So this one, space, and then let's pick up maybe another one. This one. Let's do that. Now it's 2 by 3 as expected. And let's do one more time. And let's pick up maybe this one, right? So now we can see that now it doesn't show 3 by 3. It just says seal is false, meaning it's no longer sealed, right? So that's what we wanted. So now we have unsealed the vault for our usage. Now we should be able to add this particular key. Let's do that. If we can do it now, or oops, if there is still something else that we need to do. Yep, we still need to do one more thing. All right, so is still not able to access it because the vault is locked, right? So we need to log into the vault in order to be able to do all that stuff. So unseal is one thing. So unseal is done. Now we basically need to use this root token, as we see here. Sorry, this root token. We need to use this root token to log into the vault, and then we should be able to basically add those keys. So the method is very simple again: vault login, and then followed by the, oops, I think I did not copy the key or the token. Yeah, let's copy this and put it here. Yeah, okay, so now this has been our meaning this session has logged into the vault properly after unsealing. Now let's finally create this key or this enable the secrets and see if it works. Yep. Okay, so the key is, or the secret engine has been created at /MariaDB. So now this secret engine will be storing all the keys that we add to this vault. And let's add our first key to this vault now. All right, before that, let's take a quick look at the keys or the secrets that are currently installed on this vault, right? So that is basically vault secrets list detailed. So it's going to give us a detailed output of the secrets that are currently available. We can see there are a bunch of secrets already created by default, but then there's this one, MariaDB, and this is a key value pair, right? So that's what we wanted to see. Alrighty, let's add our first key to this engine, which is the MariaDB engine. Again, this engine has nothing to do with MariaDB yet. This is just a name that we have given, right? So We should not be confusing this with MariaDB server. So let's clear the screen, and we are going to run this. So vault key value put, right? So we are going to put a key value pair in this engine, right? So this folder is our engine, and then the name of that key is going to be data, and then the value of that key is going to be this one, right? So let's run this command first of all before we execute this one. So if I run this command, so it's going to generate a random 32-bit hex value for us, right? So that's the important part. So it's going to be generating a random 32-bit hex value, and that is the value that we are going to store as our encryption key, right? So that's what this is going to do. So let's do that. All right, so we can see that the version number 1 has been already created. We can take a very quick look at the key itself, meaning what key was created. So vault kv or key value get MariaDB/1. So we can see that the version is 1, of course, right? So the version is 1, and this is when it was created, and the key name is data, and then the value for that key is this one, right? So it basically created a random 32-bit hex value for us, as we have seen earlier. So this is going to be our encryption key later on, moving forward. All right. So again, talking about the key rotation is again very simple. We just simply run this command one more time. So once we run this command one more time, it will basically create a version 2 of that of the same key data, right? So we'll have a version 2, and MariaDB will automatically, or not MariaDB, basically the Hashicorp Vault plugin that is running on the MariaDB server will use that latest key always, right? So it will use that latest key and then re-encrypt that data using that new key. So that's how easy it really is to do a key rotation. Alrighty. So moving forward, yeah. So let's go to our MariaDB server now. If we see the version, we can see that it's Enterprise 10.6.4, which of course we can also see here, right? So yeah, so we are running the enterprise version. So I have already created a simple database, and then I have also created a table. So if I do a select, it has roughly around 3,200 plus rows in that table with some text values, right? So these text values are nothing but simple column names from the entire server, right? So I've just inserted some dummy data into this database already. So if I quit from here and go to the data directory, MySQL. So if I see here, we will see our test database here, which is where we expect to see test DB, and then we should be able to see our tab, right? So this is our MariaDB table, the InnoDB table data file. All right. So if I do this strings of tab dot ibd and then head -20, if I just get the first 20 lines, first 20 strings from this table, I can see that, yeah, I can clearly see those values, or the text that is basically available in this table. So which clearly means that the data is not encrypted as of now, right? So that was the basic point, main point, that the data is not encrypted as of now. All right, so to enable encryption is very simple. So we are going to be editing our my.cnf.d/server.cnf file. So we are going to be editing our config file, go all the way down to the MariaDB section, and just simply add a set of configuration, which we are going to go through, of course, right? So I'm going to insert, and boom. All right. So what is going to do is going to load the plugin, right? So it's going to load the Hashicorp key plugin, but before we restart the server, we need to basically install the plugin first. The plugin we have not installed yet, so we need to install that before we restart the server. And then the Hashicorp Vault URL is going to be pointing to the Vault server, right? So this, again, this IP address is wrong. We will need to change it, replace it with the Vault URL. So let's get that hostname -i. So this is the Vault IP. So let's yeah, let's do that. The port is the same, and then this /MariaDB is our secret engine. Remember the one that we created here, secret engine. That is what is pointing to. All right, and then another important part is basically this token, root token, right? So this root token we need to again get from this init file, right? So Hashicorp Vault init file. So let's copy that token, Command C, and then let's replace it here, append and paste, right? So that's all there really is. So we are done with that configuration. So these are the two key things that we need to configure. Now if the firewall is open and then the server is able to access this 8200 port on this IP, then our configuration is done basically. All right, so this one basically enables the caching of the keys so that it doesn't have to access or doesn't have to query the key all the time. So it will maintain the keys within the server itself for some time unless the server is restarted, right? So once the server gets restarted, it will change the key. But of course, over time, the caching will be cleared as well. Let's say later on we stop the vault. The vault is no longer available, but because the server already has the keys in the caching, so it will still be able to work for some time, and then eventually it will not work anymore. So you need to unseal the vault again and restart the MariaDB server so that it can connect to a fresh vault and then start working. All right, so now these are standard encryption properties. InnoDB encryption of tables is set to force so that we are not allowed to create any unencrypted tables. All the tables created and new created tables and existing tables will be encrypted automatically by this. And then we are saying that we want to we want to encrypt the logs, we want to encrypt temporary tables, we want to encrypt the temporary disk tables, temp files, bin logs, then ARIA encryption also we want to do. And encryption thread, we are setting it to 4. This really depends on how many CPUs do you have in your machines, or vCPUs or cores, whatever you want to call them. My setup is very simple. I have only 2 CPUs, so I'm just setting it to one thread, because anyway my data is not that much, right? So one will be fine. And then the encryption rotation IOPS, this is an important one. So this defines how fast or efficient your encryption is going to be. So if I'm using SSD or faster storage, then I can of course go higher, but I'm just setting it to 2000 for now. But this really depends on your current setup. So you need to measure your IOPS on the server, how many IOPS does your storage supports, and then you just set this accordingly. And then finally we are just enabling the server error log file. That's all, right? So it's very simple setup. Again, we only needed to update this IP, of course. And then of course if you are using a different port, then we need to change that. And then also this one, if you are using a different engine name, because we are using MariaDB as the engine, so we're actually just using that. And yeah, and then of course the root token. So these are the important things. All right, so I think we are done. Let's save and exit this one, and let's restart the MariaDB server. See if it's able to restart, or do we have any errors? Okay, so we have some problems. Let's take a look what exactly is going on. Okay, so if I go to, if I take a look at the log file, the server log file, let's do a cat of that. Maybe I have a typo somewhere. I hope that's the case. Okay. Yeah. How silly of me. So it says unknown variable, right? So I was just talking about earlier that we need to install the plugin first before we restart the vault or before we restart the server. So yeah, there it is. So that's exactly what happened just now. So yeah, let's install the vault and then we can restart the server and then it should work, right? So just clear the screen. Let's yum install MariaDB Hashicorp key management. Let's install that. Alrighty, it's done. And then restart, and there it is. So yeah, so very simple problem. We configured the vault variables, but we did not have the plugin, right? We didn't have that plugin installed in the server. So if I do show plugins now, we can see that yeah, indeed we have the HashiCorp key management plugin enabled and installed, and then it's encryption type, and this is the SOR, the library file, and then of course we can see is a GPL license. All right, so the plugin is installed and then it should have already encrypted the database. So if I go to this table and then we will use the very simple command to, or simple way of accessing, of checking whether the tables are encrypted or not. So that there is a table under the information schema that's called InnoDB table spaces encryption. So if we do use information schema show tables, and then yeah, there is the variable, the name is here, InnoDB table spaces encryption. So if I run this SQL, select name comma current key value or current key version from information schema dot that table, the InnoDB table spaces encryption, we can see that all these table under MySQL and then the testDB tab, and then they are all encrypted using the key version 1, right? So this basically means that the first key that we installed or created or added in the vault, that is already been fetched by the MariaDB server, and then the tables should have already been encrypted, right? So this is a very quick check of seeing whether the encryption is already in place or already in action. So if I quit from here and go to var lib MySQL testdb, our database folder, and then if I run that strings command one more time, strings tab.ibd had -20, so we are getting the first 20 strings that are there in this data file. And yep, indeed we are not able to see the text anymore, right? We can clearly see the text is all encrypted. So without the plugin, right, without the vault in place, now this server or this MariaDB server is useless, right? So without the vault, the nobody can run this server. So if let's say somebody copies your data files and like for example copies this IBD files into a new server and try to start the server, it will not work because the table or the data is all junk, right? So we can clearly see. So without the vault, this database will not work anymore, right? So we can do that check very quickly now, or even before we, yeah, let's do a check on that. So if let's say systemctl restart vault, so if I have vault, I have already restarted. So if I get vault status now, we should see that the seal is now true. So meaning the vault is now sealed, so nobody is able to access, nobody should be able to get those secrets that are inserted or created in our secrets engine, right? So if I go to to MariaDB now, use testdb, select start from tab, we can still access the data because you remember we have those caching implemented, the caching of the keys. So yeah, so the server still has access to those keys, and then it's still going to work for some time, but eventually after some time, when those caches are basically voided, then you will not be able to run any queries on the server, right? So but for now, what we are going to do is we are going to just simply restart the MariaDB server just to show you how that's going to look like. So now we can see that the restart is not working anymore, right? So if I cat the server.log, we can see that it is clearly saying unable to get the key data, right? So that's what I wanted to show you, that it's not going to be able to start the server because the key data is no longer available. The vault is sealed, right? So that's clearly mentioned in the logs as well. So if somebody physically steals your computer or steals your server and then try to run it on his own environment, of course, from his own environment, he will not have firewall access to the vault, right? So, and definitely no network connectivity to the vault. So he will never be able to access the data. That's the important part here. All right. So now what do we need to do? As always, uh, we will need to get 3 of these keys and then unseal it, right? Um, so let's do that. Oops, this is a very stupid way of doing it. Vault operator unseal, and then let's use maybe the last 3 keys, right? So the first one, and then let's take the second last one, and then oops, and then the last one. Let's pick up the last key. All right, so the vault status is now unsealed, right? So let's restart the server now, and there it is. The server is able to restart now. So that's the important part. So once the server is sealed, the vault is sealed, the server should stop working after some time, right? So that's the important thing here. And then to start the server again, you need the people who are holding those keys to come down and then key in those keys so that the server can start, right? So that's the thing. Now let's take a quick look at the key rotation, right? So that's going to be interesting. Let's do that. All right, so if I can go back to the same command that we did when we added the key, the first version, right? So we are going to do that. So if I run the same command again, that name comma current key version, we can see that that tab is using the v1. So if I test db, let's do one quick thing. Tab to like tab, right? So let's create a new table and insert into tab to see. I have only one column here, actually 2 columns, but the one is auto increment values data 1, for example. Just inserted one row, tab 2, so we can see that there is one row only. So if I run that this command again, we can see that now testdb has tab and tab 1, tab 2, both are using the key version 1, right? Okay. So let's run our vault key value put MariaDB, because MariaDB is our secrets engine name in the vault as far as the vault is concerned, and then the key name is data, and then the key value is this OpenSSL random 32-bit hex value. Right, so let's do that. Now we can see that the versions are 2. There are 2 versions now for this vault. So if we take a quick look at the metadata for this MariaDB secret, right? So the secret name is MariaDB, of course, as we know. So if we just do a quick look at vault kv metadata for MariaDB, we should see that it has version 1 and then it has a version 2. So there are 2 versions created now with different timestamps, of course, right? Yeah. So now on the server, if I run this command again, I expect to see that the MariaDB server should have already used the new key and done the encryption, right? So the current key version that is in use for these tables Now, yes, indeed, we can see that the current key version is now set to 2. So yeah, there it is. HashiCorp Vault plugin in action and talking to a Vault server which is running somewhere in your infrastructure, right? So as long as the IP is accessible, the port is accessible, then the MariaDB server will be able to start, and then you can do whatever you want. So anything or any table that you create, it should be automatically encrypted. So we can do that very quickly. Uh, SDB. So now we have tab 2 as well. Um, strings tab2 dot ibt. Okay, so I think because this is the new one, is still in the cache, is not flushed to the disk yet. So if I just simply do a restart of this MariaDB server, that should have flushed the data to disk. Yeah, so we can see already that tab2 is also encrypted, right? So we can see very clearly there's no even though there's only one record, but you can see the encryption is, yeah, is a lot of junk. So anyway, so the point was that the encryption works and very easy, and then we can very simply update the keys versions, and then or do the key rotation basically using the same way as we did earlier, using the put command, or the same, to the same engine and to the same key name, of course a different value, and then the MariaDB server will pick up the new value and encrypt again, right? So that's what it is. All right, thank you guys, that's all.